Thermal processes attack the problem of an unfavorable mobility ratio and residual oil saturation by heating the reservoir and its fluids. The heat is added either through the injection of steam or hot water, or by actually burning some of the oil in the formation. The most important effect of adding heat is the sharp reduction in the oil viscosity, and with it the resulting decrease in the mobility ratio. Increasing the reservoir fluid temperature also reduces interfacial tension, increases the relative permeability to oil, and vaporizes some of the oil. During a steam flood, steam is continuously injected into a reservoir using an injection production well pattern similar to a water flood. As the steam, shown here in light blue, moves out into the reservoir away from the injection well, its temperature drops because of heat losses, and it begins to condense to form the hot water zone, pushing oil ahead. All of these zones move toward the production wells with the benefits of higher temperature. In the steam zone, oil is actually vaporized. In the hot water zone, the oil expands, its viscosity drops, the residual oil saturation is lowered, and the relative permeability improved.
Canada's oil sands are recovered using two main methods, drilling and mining. About 80% of the resource, known as bitumen, is found between 100 and 800 meters below the Earth's surface. These reserves are too deep to be mined and are recovered in place or in situ. One of the in situ methods is called cyclic steam stimulation, or CSS. Found in formations consisting primarily of sand, the bitumen is located beneath a layer of hard rock called cap rock. In CSS, steam soaks into the oil-bearing formation, warming the bitumen so it can be pumped to the surface. The operator drills a well down to the target formation and then extends the well horizontally to access more of the reservoir. CSS is a three-phase process: the injection phase, the soak phase, and the production phase. During the injection phase, steam is injected into the well. The well is then shut in at the surface while the steam in the reservoir continues to warm the bitumen. Once the soak phase is complete, production begins. The bitumen and condensed steam or water are pumped back up the same well to the surface. The process is repeated, recovering more bitumen with each cycle. Bitumen and water are sent by pipeline to a central processing facility for separation. The water can then be recycled, converted to steam, and sent back to the well site to be used again in production. Bitumen is a valuable resource that can be refined into transportation fuels such as gasoline, diesel, and jet fuel. It can also be used by petrochemical plants to create everyday products like cosmetics, textiles, plastics, and lightweight construction materials. Learn more at cap.ca.